This is Kevin Collins with Home Theater Forum. We're here at Blue Jean Cables, continuing a series on cables. One of the top performing questions that we have on Home Theater Forum is what's the difference between a $17 and a $150 HDMI cable? So we wanted to talk to Blue Jean Cables to find out, really what's on there. So one of the things when I was doing HDVD is kind of when the format wars were coming out, that was kind of really the beginning of HDMI and when that cable really started to become prevalent. And when we would go around on just showing HDVD players, we always were, the challenge of going between component or HDMI. And if we went HDMI, especially when we were doing press events and stuff like that, we had a big problem with running long cable lengths. We would get, the little pixelation that would occur, sparkling that would occur on the picture, or it just wouldn't show. And that's kind of an issue that comes up. But also there's always the voodoo on, do I need silver in my HDMI cable, and is a thicker cable better than a thinner cable? Or if I go to Fry's and buy the $5.99 HDMI cable, I'm going to give up something on video or audio. And there's a lot of people on Home Theater Forum that ask that question. The top performing thread is, what's the difference between a $17 and a $150 HDMI cable? So we're hoping that you could kind of shed some of the mystery behind that and kind of explain the science behind HDMI cables.
Absolutely. First off, the first thing I'd say is when you're worried about the difference between a $17 and a $150 HDMI cable, you have to remember that in a lot of cases, the $17 and the $150 cable may have been made in the same factory and may have cost the same to make. Price in audio-video cabling, for reasons of marketing, for reasons of history, for reasons of distribution, things like that. Price is a very, very poor metric for cable quality, and a lot of people have come to realize that, which has driven a pretty vigorous price competition in HDMI cable. Now, at the same time, there are decidedly some quality issues in HDMI cable. Occasionally, we get into an argument with somebody who says, well, wire is wire. If you hook it up right, it's going to work. And, that's true when you're dealing with low-frequency signals. It's true when you're dealing with things like DC voltage. It's not as true when you're dealing with high-speed data. And for the same reason that you can't just take a bunch of Home Depot extension cords and turn them into a Cat5 cable and run Cat5 100 meters in your home network, you can't just do anything that hooks 19 pins to 19 pins and have a high-performing HDMI cable. The most important thing for people to understand, probably, when it comes to HDMI quality is that if you have an HDMI cable which is working at the resolution and with the features, deep color or whatever you may have in your system, if it is working, if it shows no signs of not working, as in throwing those kind of sparkles onto the screen or causing lines of video to drop out, causing the picture to flash or jump, or just causing the picture to drop out entirely, you've got an HDMI cable that's doing everything for you that an HDMI cable can do. And it doesn't matter whether that cable costs $2 or $150. Replacing it isn't going to make your picture any better, make your sound any better, anything like that. The difference in quality between different quality lines of cable is going to be in what they can bear in terms of data throughput, what they can bear in terms of getting that data over a given distance without enough deterioration in the waveform of the digital signal that the receiving circuit can't reconstitute all the information that was sent by the source. And the critical thing for HDMI cable, the critical thing to understand with HDMI cable is it is essentially a data cable. An HDMI cable, it has 19 conductors, but the critical part of the work is done by 4 data pairs, 4 shielded data pairs, which are 100 ohm pairs, like the kind of thing you see in a Cat5 cable, and the impedance of those pairs, which is a function of physical dimensions of wire, physical dimensions of plastic, the consistency of the plastic, the consistency with which the shield is wrapped around the pair, things like that are what actually determine how tight the impedance is, and hence how well that digital waveform keeps its integrity over the course of a run of cable.
So what are if someone wants to if someone, you have a line of cables that you have from your tartan line all the way up to stuff that's done sourced through Belden cable. If someone's just going to do like a short, a run for an interconnect from their pre-pro to their Blu-ray player, what is, and it's just in a normal, rack, is there going to be any difference between, this, or is it more, if I'm going to be going long length, that I care more about this, or is it, about thinness, but just in terms of picture quality?
In terms of picture quality, if you're dealing with a 3-foot cable, any competently made cable is going to do everything that any other competently made cable is going to do. And consequently, in a typical kind of home theater installation where all the equipment is in one rack, the display isn't too terribly far away, HDMI cable quality doesn't really come into play. But when you start having to daisy chain things, if you're going 3 feet into a wall plate, in the wall is a cable that's going 40 feet to another wall plate. At another wall plate, there's a 10-foot cable that goes out to the display. Now you're out into a critical run length, and as you were talking about with your HD DVD experience, you will find that, in fact, in some applications, some cables just are not going to function. And early on in the days of, in the early days of HDMI, we saw a lot of non-functioning cable. It was actually a little bit difficult. The manufacturers of this cable generally hadn't gotten their product consistency to a sufficient level that people could reliably make, say, a 50-foot cable that would dependably work. That's not so much of a problem these days. Most of the cable that we're seeing is of reasonably good quality, but there are still some differences. And in particular, the one thing that we've done in cable design, as you mentioned, we source some of our cable from Belden. The vast majority of HDMI cable stock in the world is made in the Republic of China. I know one company that makes it in Taiwan. I'm not aware of anybody that makes any of it anywhere else except for us. We have our own proprietary designs of HDMI cable that are made for us by Belden Wire and Cable, made in plants in Kentucky and Indiana. And you can see what the difference is between this and a conventional cable design. This here is a sample of our Tartan 24 HDMI cable, and here's one of these data pairs that I was talking about. You can see what the data pair consists of is a foil shield wrapped around with a drain wire and then 2 wires that are twisted together. And this is a conventional twisted pair configuration. If you open this up, you see the wires are completely independent of each other. And this gives you reasonably good impedance consistency if the twist rates are kept consistent and the shield is well applied and so on, and makes a perfectly competent HDMI cable. What we did with Belden was to ask them to bring some technology that they use in the data cabling area to bear on this problem. And what they can do is maintain better impedance consistency by actually bonding the 2 wires in the pair together. So here is a Belden bonded pair, and you can see that if I try to separate these wires, they won't separate. And what this means is that you have consistent impedance, especially consistent impedance relative to handling. If I take this cable and I give it too sharp a bend or something like that, the pair bonding really makes it very difficult to cause significant impedance variations in the cable. Where you take a conventional twisted pair and you give it too much of a kink, and you'll have some performance loss. You see this in network installations sometimes when an electrician will take a whole bunch of Cat5 cable, attach it to a jack, and then scrunch up the rest of it and shove it all into the box and slip the cover on. All of a sudden you've got a non-performing Cat5 run and you don't know why. And it's because putting too much strain on that, causing the pair to open up in some places, tighten up in other places, is causing impedance variations. What we've found with the Belden cable is that for a given wire gauge, we can get the cable to perform over a greater distance. Our Series 1 HDMI cable, which is a 23.5 gauge design, is certified high speed out to 25 feet, out at standard speed out to 45 feet. The 28 gauge version of the same is certified out to 15 feet at high speed and out to 25 feet at standard speed. And when you get out to those longer lengths, that's where the fall off is. Other people will not be able to get the cable certified for such a long distance. And with HDMI, there's typically a lot of headroom. So the fact that, say, the Series 1 is certified at 25 feet doesn't mean it won't work in a high-speed application at 50. But what it does mean is that you've got a better chance of getting it to work in a high-speed application at 50 than you do for a cable that was only able to make certification at 20 feet in high speed.
When you talk about high speed, to help our viewers understand that, it's not like if I have, Cat 6 cabling at my house for doing networking, I can think of something. But in the realm of like home theater, what does high speed really mean? Is it like 1080i, 1080p? What would be the application that someone cares about? What speed the cable's at?
Your conventional high definition resolutions and conventional color depth are all within the range of what we would call standard speed. Their standard speed takes you up to basically the resolution of 1080i or 720p in HDMI at standard 8-bit color depth, and without any other features added onto that like 3D and such. If you are stepping up the color depth, if you step up to 1080p, which gives you double the frame rate, if you are going to 3D, if you're going to some of the other applications like 4K by 2K, those take the bit rate that the HDMI cable has to handle, and they push it over the what they call the Category 1 or standard speed threshold and push it into the high speed area. So, it's a bit complicated. You've actually got to work it out for each application. If you say you're running 480p, but it's in 3D and with 12-bit color depth, right off the top of my head, I couldn't tell you if that's a standard speed or a high-speed application, because you've got to work out how that frame rate and color depth and all apply to generate the final bit rate.
So how's a regular Joe supposed to go to maybe even your website or someplace and know if the cable is high enough speed for what their application, given the the kind of catching on of most Blu-ray players will output 1080p 24 now. A lot of them will do 3D. It kind of sounds like you'd need to have something that might be more than just the standard HDMI cable.
Actually 1080p 24 is a standard speed application because you've cut the frame rate actually below the standard 30 frame rate, and so although you've got the extra, you have the extra resolution, but you've lost the as they say temporal resolution. But I've been actually meaning to put on our website a high-speed standard speed calculator so that people can work out what the bit rates are on a lot of these things. It's not easy to know. What I think is important to know, though, is that when you do cross over into high speed, this isn't it isn't an all or nothing proposition. A standard speed cable isn't necessarily going to stop working. Because there's always a lot of headroom in the HDMI spec. The way the spec is written, devices putting out a signal have to put out a signal meeting a certain minimum quality standard. Devices receiving a signal have got to be able to accept a signal of a certain degree of degradation and lift that out of the muck and noise, so to speak, and get it up to where there's no data loss. And a cable is certified on the basis that it should be able to take the very worst compliant source and hook it up to the very worst compliant display and still produce a correct picture. So in practice, there tends to be a lot of headroom. Sources are not worst case sources, displays are not worst case displays. And so what we generally counsel people to do is not worry too much about the whole high speed, standard speed thing. Plug things in. There's only one way of actually knowing in HDMI whether something's really going to work, and that's to plug it in and see. And if you plug it in and you find that you're getting sparkles on the screen, then cable quality is at least one of the things that you need to consider in terms of trying to repair the data loss problem.
What would be the other things that you would look at?
Well, the other things you'd look at are the mode of installation, any kind of couplers, wall plates, things like that, are always going to introduce impedance bumps into the run. And so it might be that you have a nice, neat wall plate to wall plate installation. Maybe you need to scrap the wall plates and do this on the basis of having a cable that comes out of a port in the wall, so that you don't have these couplings along the way. Certainly, sometimes it's just a matter of wire gauge. There are different kinds of loss going on in HDMI cable, and one of the things is just a certain amount of signal amplitude loss. And sometimes simply going to a larger gauge cable will resolve a problem, even if the cable is not particularly of a higher quality construction. The other thing, of course, is always to look at what your sources and what your destinations are. We see a lot of trouble with computer video cards, things like that. If you've got a video card, especially say that's putting out on a DVI interface instead of an HDMI, and you're running that into an HDMI display, it may well be that that the video card isn't putting out a very high quality signal. So, all of those kind of considerations, and there are installation considerations. Have you made the run as short as you can make it? Have you avoided kinking the cable around a corner? Things like that. Sometimes surprisingly small things can actually make a considerable difference to whether a particular installation works well.
So it sounds like what I'm kind of gathering is if you're using an HDMI cable for like an interconnect in, your 3 to 6 foot thing on your rack, then it's pretty easy to go test that out. If it works, it works, and you're not really going to see any. If you're going to see a visual thing, you're going to see a visual thing, but chances are you're probably okay with the $17 cable versus like the $150 cable.
Yeah, or even the $3 cable.
But then if you're going to be doing something like a long run where you're going through the wall and stuff, then things like a bonded cable are probably going to make it more tolerable to bends than you would have with a non-bonded twisted pair cable.
Right, and are going to just give you better impedance consistency, which will allow a slightly longer run, or in some cases a substantially longer run. But it's always a little bit difficult to predict because the problem of how much headroom you have in your devices is always unquantifiable until you start plugging things in and trying them.
So you talked about interconnects, which then kind of gets me to the actual termination of the HDMI cable. With analog cables, you'd always have people saying, "Oh, we use the best interconnects, and we do it with this kind of a process, et cetera, et cetera." How this looks like it was molded or something like that. How do you guys do your own HDMI termination, or where does that occur?
We don't. We initially, when we went into HDMI, we intended to try to bring all our HDMI termination in house, and it's still a live issue, and it's still something that we might do, but. The difficulty is that there are 19 wires in an HDMI cable, and they go into this rather tiny, 3/4 inch wide connector. Typically this connector, if you were to peel this off and take a look inside, all it's got is a little PC board that's maybe 1/2 to 3/4 of an inch long hanging off the back of that connector. Wires have to be soldered down to flat contacts, and then the whole thing has to be encased in a plastic overmold. And it's a very labor-intensive process. Early on, we always thought there must be a machine somewhere that does these, and it turns out that the secret of HDMI cable assembly is a lot simpler than that. It's very, very low labor costs, and consequently, although, as I said, there is our cable stock made in the United States, and there is a little bit of cable stock made in Taiwan, to my knowledge, there isn't an HDMI cable you can buy anywhere in the world that isn't terminated in China. The factory costs are simply so much lower there, and that's what we've found is we've had to take the cable, have it made for us in Kentucky and Indiana, and export it to China temporarily to have it connectorized and bring it back in. This is something which a lot of people have been looking at, and there are some proposals out there, some insulation displacement connector arrangements and things like that, and that's something we'll be continuing to look at to see if we can bring at least some of this cable termination business in-house. But right now, the most practical way to terminate HDMI cable is in China. Very inconvenient if you want to install a connector in the field, very inconvenient if you want to repair a broken cable. But that's really the state of the art right now.
So basically, if someone's going to terminate, if they're going to be even like bonded, then they still have to somehow take the bonding apart and then get it and then lay it down. And right now it's someone manually looking at all 19 things to fit it into here, and
Right.
it seems like that would be ripe for error to have quality control problems. How does the testing go for everything that comes out from the terminated state that you can put a stamp on there and saying, yeah, we know it's going to have this data speed at this length or go above? What's that process to
Well,
ensure that?
there are sort of two levels of that. I mean, on the one level is at the certification end. We submit cable samples to an independent laboratory which tests and verifies and issues the certificate of compliance, which says that someone without an interest in the question certifies that this cable meets certain standards for things like skew and impedance tolerance and things like that. Now, on a production basis, obviously we don't send every cable in for a compliance test because that's thousands of dollars at a time. At a production level, we've been very pleased. I've visited the factory that does the termination of our HDMI cables for us, and what they do is a variety of sort of in-use tests and stress tests. They terminate the cable, and if something's going to break due to an excess flex injury, it's typically going to break quickly and early. And so what they do a certain amount of stress testing. They actually take each assembly, they plug it into jacks, they tweak the wire to make sure that if we bend it this far and this far and this far and this far, we don't get a broken connection at any point. Obviously there's continuity testing on all the pins. They typically test it on an actual display just to say, yes, indeed, this makes a picture. And that's about all that is really needed to be done. They do a little bit of sample testing from time to time in terms of things like the pulse strength of connectors. And there are limits to what you can do in terms of termination integrity on HDMI cables. Something we're always trying to stress to people is that if you're going to be pulling this through a conduit or something like that, you need to follow some very, very careful practices in terms of how you anchor your pull rope to that cable, because 1924 gauge wires soldered into little points this big will not take a great deal of pull stress, and it can be a very frustrating installation for somebody to pull a 50-foot cable through a wall at great effort and then find that once it's in the wall it isn't passing signal at all.
What difference does it make, if someone looks at this and they see the thickness, there's kind of like this initial impression of, wow, this is better than if I pick up this and it's like, this can't be as good. What's really going on between, why is it the insulation? Is it just the gauge of wire? And it's because this is thicker because I can go longer distance than this? Is that what
That's essentially it. The things that control dimensions, because these are data pairs, the dimensions of the wire and the insulation and the shield are all critical. And consequently, for a given wire gauge on the data pair, there's a certain kind of mandated cable size just by the facts of engineering. You got to have this much dielectric on the outside of the wire to make a 100 ohm pair. You got to have this much shielding material. It's all got to be cabled together. You got to stick the overall shield on it. You got to put a jacket on it that will pass a flame rating, which is important. The outer jacket is polyvinyl chloride, more resistant to flame spread than polyethylene, which is what cable dielectrics are typically made out of, PVC making very bad dielectric. So you got to have enough jacket material for that. So in most cases, the diameter of an HDMI cable overall is dictated by the wire gauge being used in the data pairs. And of course, that makes for some practical challenges. On the one hand, if you're doing short runs, flexibility is a wonderful thing, and a 28 gauge cable will give you very high flexibility, but it doesn't give you the same kind of run length. If you want to go 50 feet, you do not want to try to do it in 28 gauge cable. 24 gauge cable, on the other hand, will give you excellent run length, but it's quite thick. And there's some 22 out there, and that stuff is massive. It's very inconvenient in terms of product flexibility, but it'll sometimes get you over a distance that something else will not.
It also seems like if this was going to be in your as a patch cable, it's kind of sticks out a ways
Yeah.
to go from your Blu-ray player to your pre-pro.
Well, absolutely. And in fact, if you take, say, this is our 28 gauge bonded pair cable, you can put a pretty good bend. Typically, the recommendation is to keep your radius bend down to about 10 times the diameter of the cable, and I'd say that's a good rule of thumb in this case. You take, on the other hand, the 23.5 gauge, and you want to take a radius bend. That's pretty tight. I'm putting a decent amount of stress on this cable, and you wouldn't want to stress it much farther than that. There is a tendency for people in installations to stick this cable into the back of the DVD player and then shove the DVD player up against the wall, and they'll sometimes shear that connection right there just by putting too sharp a bend on the cable. And so flexibility is one of those things people it's the kind of thing engineers worry about when they're worrying about cable, and it's the kind of thing that the consumer ought to worry about, if he wants a smooth and simple installation. It's great to be able to use smaller gauge cable when appropriate, when the run length will tolerate it, and limit the larger gauge to mostly the longer runs, or to situations, you may have a daisy chain situation where you want larger gauge cable at every link of the chain, because if you're going a few feet into a wall plate, 40 feet in the wall and a few feet out the other end, it may well be that you want a 24 gauge cable at every stage of that.
What's you read a lot about people have silver as a solid core. What's your opinion on what the material is in the cable in terms of quality? Is it just better speed, longer distance, or does it make no difference?
It makes very little difference. In the case of an HDMI cable, the critical thing. Well, let me back up there. In the case of an HDMI cable, materials in and of themselves don't make a great deal of difference. It's dimensional control in manufacturing. It's something which is actually very hard to see, very hard to measure unless you can take this cable and run something through it and put it on a scope that makes all the difference. Silver will give you a very slightly higher conductivity than copper, and that may give you just a fraction of a dB and allow you to stretch a cable length a little bit, but it's really a little bit. I know that last time I looked at it, it seemed to me that we could probably stick about another foot onto a 50-foot run if you were using silver for the conductor. It has to be borne in mind too that not all of your losses in HDMI cable are losses of amplitude. It's not loss to resistance, which is what the silver versus copper thing resolves. It's losses to things like return loss, which have to do with dimensional controls. And so the funny thing about cable is that although there's a lot of exotic material out there, and there are a lot of odd sort of physical recipes for things, in reality, the cable used by professionals in critical applications is made out of the same stuff that the very cheapest cable is made out of. And the issues of dimensional control and just product consistency are really what make the difference between a low quality and a high quality product. Mm-hmm. So in the case of our HDMI cable, we use solid copper conductors in our data pairs. We could go to silver, but it would add a lot of cost, and it would do virtually nothing.
Well, the one last thing I wanted to wrap up on was you talked about the coating, the outside, and you said there's two different kinds. Is there something I should be concerned about if I'm just in a rack versus if I'm going through in-wall? Any code things I have to worry about that are associated with the different types of coatings that are on the outside? Sure.
Well, most jurisdictions in the U.S. use the one version or another of the National Electrical Code, and the National Electrical Code has a number of rating classifications for communications wire and cable that are to be installed in buildings. And the ones you see most commonly on consumer products are CL2, CL3. You see there are quite a lot of others. There's C, there's CMR, there's CM. There's a whole slew of these National Electrical Code classifications. In the case of a residential installation where you're not in a multifamily dwelling, if the cable has any of these ratings at all, it is legal to install in a wall. If you're in a commercial installation, you really need to have a little more sophistication about codes. If you're running cable through a plenum, it's got to have a P on the rating to indicate plenum. If you're running it through a cable riser, it's got to have an R. You know, ratings will depend on voltages and things like that. In the case of HDMI cable, you're going to see some products that are unrated, and that's fine. For a patch cable, there's no need for it to have an in-wall rating. But anything that you're going to install in a wall, you want to make sure that it has an appropriate NEC rating that allows you to do that installation.
So for your HDMI cables that you have, you kind of range from what you call your tartan line.
Yes.
And that's sold via Blue Jeans Cable or on Amazon.com, and that cable is comes where you source it from China.
That's an all Chinese product.
And then there's your specific Blue Jean cables where you've gone out and figured out your own cable that you've done specially through Belden, and then ship
Right.
it to China, have them terminate it to a particular length, and then come back and sell it. So all the engineering and stuff here is done in the United States. The cable's made here in the United States, but the termination is done in China.
That's right.
And so people have a variety of things that they can choose from on the HDMI cable part.
Yeah, absolutely. And so the tartan cable is very price competitive with other Chinese cable. The Belden stuff, it just costs more to make. It's the most expensive HDMI cable to make in the world, and so it costs more. It doesn't cost as much as some things out there do, but it does cost more.
Okay, well, thanks for your time, Kurt.
Thanks.